Mr. Lee, it is your time, my friend. I learned a little bit with this amplifier. I did. Gentlemen, what we were talking about tonight is I've got myself an ass kicker. And it was a 12 pill. It was a 2-drive and 12. And my buddy Lee said, I'm going to send this thing out to you and I want you to turn it into a 16 pill. And I said, that's great. First, we got to figure out what transistors are in it. And he says, well, I black dotted off all the tops. So I had him take and spray a little bit of carb cleaner on top of a Q-tip and get in here and wipe. He sent me a picture, and I was able to figure out that it's got SRF 3662s in it. So I've ordered up 4 more SRF 3662s and got the same output transformers as that they use at Ass Kicker. There's some characteristics to this thing I like, and there's some characteristics to this thing I don't like. Just anyhow, we're not going to go into that. I talked with Lee about all of those things, and in the long and the short, I went ahead and I built in the Ass Kicker style, and we got the thing working flawlessly. In theory, maxed out this thing because it's got SRF 3662s instead of Toshiba 2879s. It's going to do about 3,600-ish to 3,800 watts peak envelope power. And that's just because of the transistors. The 3662 produce about 10 to 15 watts less per device, and they take about 10 to 15 more watts per device for drive. They were the top dog until the 2879 came along. But there for a minute, the SRF 3662s were cheaper than the Toshibas. Now they're about the same price. But the 2-pill driver section, Lee, was right here, if you remember. Here's your old 2-pill driver section. And this is actually all the parts that I changed out or removed to make this thing work. I went ahead and I put a little button on the front of this thing. A little tiny spotter smooge on the front. Put a button there because we took the knob out. And then I went to making the ports. So I cut up a couple transformers and I made the ports the way that he makes them. And then I learned that if you take 3 resistors and culminate them together off of each port, it changes the amount of resistance that's present inside the box. And I was having a hard time getting the input tune to lay down on this thing. I'm going to circle back to that. So as soon as I stripped those 4 resistors off and went to 2 and made it a balance, because this is a splitter and this is a splitter for the input. Here's an output combiner, and output combiner. Okay, now the RF's running around the whole box at 100 ohms with direct fed wire. Now there's people out there that are divided. They either like this style or they don't. I've worked on some Foxy built boxes that were built like this back in the day, and they run like raped animals. This box runs fairly well on its wattage output, but the amount of amperage that it takes to get the watts out, it's another thing. But this box is clean and it's running perfectly fine. So the first thing that I did when I went to go do the tune is I went and I tried to talk through the box. And I was getting about 20 watts of reflag. And what I figured out is these points on this relay are so scored that I polished them and polished them and polished them and polished them, Lee, and it just wasn't going to happen. If you can sit there and you can look at the top of this relay, you can see it's actually kind of canted back a little bit. So instead of you having a problem with it in the future, I took that relay out, replaced it with its exact replacement, except I put it inside the cabinet. I left the body on it, and instead of cutting the wires off and having them come directly back to the coax connector, I went ahead and added normal jumpers. The other thing that happened, Lee, is that I noticed from the stock primary splitter unit, which is like this, coming off, going over to this input splitter, the coax is about 3.5 inches shorter than it is this way. If you notice, the coax goes all the way across. I made those even, and I'm not saying that in any way other than I just made the coaxes even. And then I figured this out. When the key-in transistor finally chooched out, that made me pull the whole circuit out and look at it. And what was going on was there was a 100 puff capacitor here. So omnipresent on the circuit at all times was 100 puff worth of capacitance on the pass-through and on the input, because it can travel through the transistor to ground. It took me a minute to get my head wrapped around. So now what I've done is you got a whole brand new key-in transistor in circuit, and that's a 10 puff capacitor. As soon as we did that, lights came on. Input reflect went way down, of course. Now, I don't know if anybody's ever been in this thing or worked and replaced that keying circuit, but it is what it was, and that's what I found. So the splitter circuit, let's talk about this. So the RF comes in primarily, it comes in from this coax connector, comes across, and it was just a piece of wire. I changed it out to a piece of coax so it could be balanced. Sorry, I'll get that in frame. This splitter that was in there, of course I changed the wire that was on it, playing with it. But the splitter that was in there was getting screaming hot. I could sit there and look at it with the FLIR and I'd be like, oh shit, that's 180 degrees. I changed it out to a more conventional 2-to-1, and then I had to add a little bit of capacitance to it. Because stock there was only 30 puffs worth of capacitance at that feed point. I ended up adding another 20 puffs to it, and it laid down like flat. So now, when we go and we're going to hit it with our 2x4 here in a second, we're going to see about 5 watts of input reflect, which is screaming great, nice and flat. The other thing I haven't had to deal with in a long time, and I mean a long time, was that when you put the lid on the amplifier, the whole tune aspect ratio of the amp changes. Because there's so much bare 100 ohm wire in this thing, or just bare wire, that when you put the lid on it, the proximity of the wire to the cabinet body changes its input tune and its output tune. I haven't dealt with that in a while. It threw me for a minute. I was like, oh wow. So I pulled the lid back off and I retuned it. But this thing drinks the amperage, Lee. I mean, it drinks it. When I had it over here on 14 volts when I was initially testing it, we were seeing 380 amps to 420 amps worth of draw to produce 3,100 watts. Or if you do the math, that's about 44 or 45% efficient. But then when you bring the voltage up, the amperage drop way off. So we're going to run it on the 600 amp supply that's down below the bench, and we're going to run it on 15.5. So fully modulated when I go on audio. Internally, the voltage on the box is dropping to 14.5, which is pretty cool. The other thing I want to point out to you, Lee, is that this isn't very safe. This 150 amp Anderson clip, I would probably strongly suggest to you, Lee, that you replace this connector and go to welder twist locks. They can carry a whole lot more amps. After running this box for a little bit, you can sit there and look at the FLIR, and you can see from this connection on, going this way, the positive and the negative wires are incredibly warm. And that means that there's an amperage restraint that's going on right here at this connector. So either you can go to the 300 amp Anderson clip, or you can go get yourself some 300 amp welding leads that twist lock. Here, hold on, I'll grab them for you so you can see it. Here, I'll grab this set here. By far, a vastly superior form of connection is this here. These are your welding plug. You got your male and your female. Obviously, female is the one that's got a hole. The male is the one that's got the digi that hangs out the end of it. The digi-widgy. And they slide inside of each other. You twist them, and they lock up. They carry a whole lot more amperage through one of these connectors than what you can get through one of the Anderson clips. Just thought I'd give you a little heads up, since this box is amperage hungry. It's just amperage hungry. That's all there is to it. The more amps you can feed it, the better off you are. Now remember, Lee, these are SRF 3662s. So you're good to go on the volts a little bit. I mean, you're good to go on the volts a little bit. You can go 16, 17, no problem at all, and never have a worry about it. And when you go up to 16, 17 volts, you'll see a huge output power difference. So with all that aside, let's get on with the testing. Lee, your amp is done. When we come back, the lid's going to be on it, and it's going to be ready to come home to you. But a little bit of ass kicker technology mixed with a little bit of BBI technology. All right, see you here in a second, Lee. Okay, Mr. D, here we go. 2x4, getting driven by a 2950. It's a 50 watt slug and reverse between your new 16 pill. It's a 5 watt slug and reverse back from the Bird 10,000 watt dummy load. 1,000 watt slug and average, and 1,000 watt slug in 5x multiplied position. So now I'm going to put this on the tripod. Let's see if we can make this a little bit steadier of a video for you guys to watch. Okay, so none of this is going to change. Now, I got to give credit's due. Drop Mall, you got some badass fans in this box, bro. A lot of amplifier users would not want to listen to the level of noise that comes out of an amp like this. Me personally, I don't give a fuck. I'd rather have a ton of air moving through my amp and a little bit of background noise than not enough air in the box cooking to death. This amp moves some friggin' air. And I'm here to tell you, I am copying you straight up. And I'm going to go get some of these fans for some of my own stuff, because these fans are awesome. Super high velocity, massive amount of air. And I'm talking massive amount of air. It's all the way over here on the other side of this workbench. It's flipping papers up and stuff coming out of the vents on the back of this 16 pill cabinet. All that aside, just saying, them Soyos or Sanyos or whatever they are that are on the inside of this thing are insane. But they are going to be a little bit loud. So here we go. First off, let's talk through the box. So, hello. 4 whole watts of reflect, and that's with about 1100 peak, audio, and about 350 bird. So we're going to put 350 bird in it. We're going to get a 10-to-1 response. We're going to get 3,600 to about 3,900 watts out of this box. And the bird numbers are a little bit low. Of course, everybody's system's going to vary a little bit. But let's watch it go. Listen to them high volume fans. I friggin' love it. Hello, audio. 1,000 bird. Hello, audio. And 8 watts of input reflect. Which all in all is pretty good, if you think about it. 1,200 in, 8 coming back. That's a 1.02. So, we're not going to worry about that input reflect meter anymore. Hello, audio. We're going to go over and look at these two. And through the power of Zoom, hello, audio. Hello, 111. There's our max dead key, you guys. That's a 3,200 watt dead carrier right there I threw. Y'all catch that? Watch this meter. Boom, in the corner. I can dead key the same that I can modulate to. Hello, audio. So I was trying to tell you that the average number is really determined by a lot of other things other than the amp. But I'm telling you, this box is solid. I just threw a 3,600 watt dead carrier. A 5,000 watt slug in the average hole. Enough said, right? Now watch this. repeat kit. It's amazing how that 5 to 10% tolerance makes a difference between how meter A and meter B reads on average, right? Lee, this amp is screaming, brother. It's absolutely pushing for what it's got in it for transistors. We could get more out of it. We could go in and completely redesign the box, but there's no point. Get it, run it, play with it. You don't like it, send it back. I'll change the whole damn inside the amp. I don't care. It's just that good. God, I love these fans, dude. You can't get this amp hot. When you're moving that much air through the box, you don't have to worry about burning nothing up. Sit around, oh, it's loud, it's giving me a headache. Give me a break. We move air, we're in radio. All right. Lee, that's it, buddy. You're done and done, man. I'm going to take this in the house, and I'm going to hand you off to my beautiful wife, and she's going to get a shipping quote, and I'll give you a call, and we'll get this thing sent back to you on Monday morning. So on that note, guys, I'm out of here. This is Friday evening, and I'm hoping to get a bunch done this weekend, try and make a lot of people happy, get a bunch of dudes 10-8 and straight, because Monday I got to jump right back into new builds again. This is a working weekend. And they will be working weekends, every single one of them, all the way up to the Bakerman BBI break, which is coming up next month. And I will be at Manchester, everybody. I will. I called and I got my hotel room today, booked my airline tickets today. I will be there. I'm going to bring a whole bunch of goodies with me for everybody to buy, and a whole bunch of shirts, and a whole bunch of this, that, and the other thing. It's going to happen, Captain. It's just the way it is. So, guys, come put your hand in mine at either the BBI Bakerman break or over at Manchester this year. And I do believe I am going to, I haven't talked to Feel Good lately, but I do believe I'm going to the Tyler, Texas break. Yeah. Gentlemen, my name is BBI. And without a shadow of a doubt, I am the biggest mud duck in Idaho. If somebody else comes along and builds something bigger than me, or buy something bigger than me, I'll just go build something bigger. It's what I do. It's what I do. Look, we're all in this hobby to have fun. And I'm out here trying to help people and make people 10-8 and straight. And I appreciate y'all's support. I appreciate every single one of you guys sending me up a project. I know it's a long wait, but man, there's one of me and there's about 1 million of you, and I'm trying to help you all out. So you do me a favor, if you're watching this for the first time, click subscribe right down there. And if you need to reach me, call that number right there, or the same number at the beginning of the video, the end of the video, or in the extra disclaimer credits. I'll do what I can to help you out. Guys, you have a good night. I'm off to go work on something else and make somebody else 10-8 and straight. I'll see you, bud. I'll see you, Lee. I'll call you tomorrow. Guys, I'm out. Bye.